So what we're going to look at 7.6, and these are called radical equations. And the key thing for radical equation is going to be this. Check your answers. You want to check your answers. You can do everything right. You'll get some answers. None of them are actually correct. They don't actually work. So you'll actually have no solution for that equation, even though you've done all the techniques correct. So you want to check your answers to make sure they do work. So let's take a look. So the technique we want to do is we want to square and to eliminate the radicals. So let's say we have this. Well, we want to cancel this radical. So what we're going to do is we're going to square it, and that's going to make it go away. So you can kind of think as squaring is the opposite of square root, just like cubing is the opposite of cube root. So these two are going to act as opposites. So are these. In fact, in general, I have an nth root for these equations. We're going to treat these operations as opposites. They cancel each other. So to get rid of this square root, we're going to square it. But what we do to one side, we still have to do to the other. Again, because of that equal sign. So this and this will cancel out. We'll get 5x minus 1 is 64. Add 1 to both sides. We'll get 5x. 65. Divide both sides by 5. We'll get x is 13. Now, hold on now. We got to put an asterisk on this. We need to check the answer to see if it works. So we claim x is 13. So does 5 times 13 minus 1 and then square root it, does that equal 8? Well, does 65 minus 1 square root give you 8? Or does the square root of 64 equal 8? It does. That is true because 8 times 8 is 64. So that means x does equal 13. So let's try another one. So let's say we have this. Well, what we want to do first, let's isolate this radical and then square it away. So subtract 11 from both sides. So we solve for the radical. Now already there's a problem because this is a positive square root. If it's positive square root, how can it be negative? Well, let's keep going. You'll see what's going to happen here. So square this, So these will cancel. We'll get 2x plus 5 is equal to 25. Subtract 5 from both sides. We'll get 2x is equal to 20. Divide by 2, divide by 2. We're going to get x is equal to 10. So what's going to happen if we do this? Well, let's say we plug in 10. Does 2 times 10 plus 5 square root plus 11 equal 6? Well, does square root of 20 plus 5 plus 11 equal 6? Or does the square root of 25 plus 11 equal 6? Well, the square root of 25 is 5. And that does not equal 6. So now if this was a negative square root, we would have negative 5, and negative 5 plus 11 would equal 6. Not going to happen here. So this has no solution, or we put the symbol for the empty set. So let's take a look at another one. So once again, we did the steps right, but it just didn't work. That can happen. So let's do this. Let's say we have now again, the thing you want to do, isolate the radical. So we're going to basically solve for the radical. Minus 1, minus 1. Now, to cancel this radical, we're going to square it, but what we do to this side, we have to do to the other. So we'll end up squaring this. Now this we're going to FOIL, or you could use one of the standard forms. What you'll get is x squared minus 2x plus 1 is equal to, and then here the radical and the square cancel, 2x minus 2. So this is a quadratic. So let's move everything to the other side. So x squared minus 4x plus 1 is equal to negative 2. Almost there. And 2, and 2. And we're combining the like terms. Here we go. Now we can solve this using the quadratic equation or the quadratic formula for this quadratic equation. Or we could do it by factoring. So guess and check, because there's a visible 1 on the x squared. And two numbers that add up to negative 4 but add up to 3. Well, negative 3 and 1. So this means x could be 3, x could be 1. So we have two answers to the test. Let's see if they work. So let's see here. Now for x equals 3, does 3 equal 2 times 3 minus 2 plus 1? Or does 3 equal 6 minus 2 plus 1? Or is 3 equal to the square root of 4 plus 1? Well, it is. Square root of 4 is 2. So that is one of our answers. Now let's check this other one. So does 1 equal the square root of 2 times 2 times 1 minus 2 plus 1? Does 1 equal square root of 2 minus 2 plus 1? Does 1 equal square root of 0 plus 1? Well, it does, because the square root of 0 is 0. 0 times 0 gives you 0. So 1 does equal 0 plus 1. So that means for our answer, we have 2, 1, comma 3. And that's it. Now let's see here. Now let's say we have something like this. So what we can do is square both of these, and that's going to make the square roots go away. And we'll subtract 5x from both sides. Subtract 2 from both sides. And we get x is equal to 1. So this is the solution we want to test. So, does 6 times 1 plus 2 square root equal the square root of 5 times 1 plus 3? Well, does the square root of 6 plus 2 equal the square root of 5 plus 3? Well, it does, because this is the square root of 8, and this is the square root of 8. It works. So our answer is just the set containing the number 1. All right. So if we have a cube root, let's say we have this. So we've got the root by itself. Good. So now we cube both sides. this is what we're going to get. Then we solve for x. We get x should be equal to 5, but we want to check to see if this works. So is the cube root of 6 times 5 minus 3 equal to 3? Or is the cube root of 30 minus 3 equal to 3? Well, we're going to be asking about the cube root of 27, and that is equal to 3, because 3 times 3 times 3 is 27. So it works. So our answer is the set containing the number 5. All right. Now let's say we have something like this. Now, this is tricky because we have 2 radicals. So what we want to do is isolate one of them and then square both sides, and then we'll isolate the last one and square both sides. So this one's already isolated, so let's square both sides to eliminate that radical. A little more room here. So on this left side, of course, everything cancels. Right side, not so easy. We're going to have to FOIL this right side. So, or we can use a standard form. This is an a minus b squared, or so we'll get a squared minus 2ab plus b squared. This is a, and this is b. Or you could FOIL it. You could do square root x minus 2, square root x minus 2. And you could FOIL that if you want. You'll get the same answer. But let's use the standard form since it's up and running. So we'll get x minus 8 is square root of x squared minus 2 times square root x. Remember for the special form that the minus is not included. And then on the 2 here, it's not included, or here. So what we're going to get, x minus 8 is x minus 4 square root x plus 4. So what we could do, subtract x from both sides. We'll get minus 8 equals minus 4 square root x plus 4. Now subtract 4 from both sides, because we're solving for the square root of x. We get negative 12 equals negative 4 square root x. And now divide by negative 4. We get 3 is equal to the square root of x. So now we square both sides. And so what that's going to give us is 9 is equal to x. Now this is a guess. Is this actually going to work? Let's see here. What problem was that? All right, so let's find out. So we have square root x minus 8 is equal to the square root of x, let's see, minus 2. So is the square root of 9 minus 8 equal to the square root of 9 minus 2? Again, we're replacing x with 9. We think 9 is the answer. Well, this will be the square root of 1. This is going to be 3 minus 2. So is the square root of 1 equal to 3 minus 2? Well, the square root of 1 is 1. And sure enough, 3 minus 2 is 1. So it works. So that's going to be our answer. All right. So let's take a look at something like this. So let's say we're going to solve something like this. Well, what we want to do, we want to isolate one of the radicals. So we can isolate this one. And the way we could do that, subtract square root of x plus 4 from both sides. Now what we're going to do is square both sides. So that'll cancel. And what we're going to get, x minus 4 equals 4 minus square root of x plus 4 squared. Now, again, you could FOIL this. You could go square root x plus 4, 4 minus square root x plus 4. Because when you square anything, you're just multiplying it to itself. So let's do the FOIL this time. So first, 4 times 4. Outer is 4 times negative square root x plus 4. Inner, negative square root x plus 4 times 4. And then for last, negative square root x plus 4 times negative square root x plus 4. So what we're going to get on this other side, on the right side, we get 16. Well, first, let me go back to what we had on the left side. So on the left side, remember we had x minus 4. And then on the right side, we're going to have 16 plus, well, this is going to be a minus. This is a negative. Negative times positive will be negative. So 16 minus 4 square root x plus 4 This will be another minus 4 square root x plus 4. Minus and minus is plus. Square root x plus 4. Square root x plus 4. Now what's going to happen here, these square roots will multiply, and well, they're just going to cancel out essentially. This is like square root 2 times square root 2 equals 2. Square root x plus 4 times square root x plus 4 will equal x plus 4. So we'll get x minus 4 is 16. Combine these two terms. They have the same radical, so they're the same terms. Minus 8 square root x plus 4. And this will be plus square root x plus 4 times square root x plus 4. It's just x plus 4. Gather some like terms. 16 plus 4 is 20. And then we have minus 8 square root x plus 4 plus x. So we've eliminated one of the radicals, finally. We've got one more to eliminate. So let's solve for the square root x plus 4. So let's subtract x from both sides. Subtract 20 from both sides. Divide both sides by negative 8. We're going to get a positive 3. So we finally isolated this. Square both sides. These will cancel. So we'll get 9 equals x plus 4. Solve for x. Subtract 4 from both sides. And we get 5 is equal to x. So with 5 equal to x, that's the one we want to test. So let's find out. Well, let's replace x with 5 and see what happens. Is it true that the square root of 5 minus 4 plus the square root of 5 plus 4, does that equal 4? Or is the square root of 1 plus the square root of 9 equal to 4? Well, 1 plus 3, square root of 1, square root of 9, that does equal 4. So 5 does work. And that's going to be our answer. Let's see. So let me do one more. Let's say we have this. Well, I do want to show one other, a couple more. So again, let's try to isolate the radical. Subtract 4 from both sides. Now, dividing by 2 isn't really much of an option here. So if we want, we can just square both sides right now. I mean, you could try to divide by 2. I just think it'll make it harder because you'll get a fraction on this side. So squaring these, this will become 4. This will be x minus 3. So the square, what's happening, it's being distributed as an exponent to the 2 and to the square root. 2 squared is 4. Square root x minus 3 squared, that's just x minus 3. Over here, we can use the, we could FOIL, or we could use the special form. And we'll get our a squared if we do special form, minus 2ab plus b squared. And here we're looking at a minus b. That's what we're looking at. So this will be 4 times x minus 3. This will be x squared minus 2 times a times b. That'll turn out to be 6x. B squared, that's 3 squared, 9. Now we're going to distribute this 4. Subtract 4x on both sides. Add 12 to both sides. We'll get 0 is x squared minus 10x plus 21. So again, it's a guess and check question. 2 numbers that add up to negative 10, multiply to 21. Well, that's x minus 7, x minus 3. So this means, using our zero product principle, when x is 7, the whole thing becomes 0. Or if x is 3, the whole thing becomes 0. So now we have 2 solutions to check. Let's see, that's this one. So let's try x is 3. Is it true that 2 times the square root of 3 minus 3 plus 4, does that equal, well, 3 plus 1? Or is it true that 2 times the square root of 0 plus 4 equals 3 plus 1? Or is 2 times 0 plus 4 equal to 4? The square root of 0 is 0. Or 0 plus 4, well, that is true. It does equal 4. So 3 does work. Now let's try 7. It is possible for one solution to work, the other solution not to work. That can happen. Let's see. So is it true that 2 times the square root of 7 minus 3 plus 4, is that equal to 7 plus 1? Again, we're letting x be 7. Or is it true that 2 times the square root of 4 plus 4, is that equal to 7 plus 1? Or is it true that 2 times 2 plus 4, is that equal to 8? Well, sure enough, 4 plus 4 does equal 8. So x is 7 works also. So we have 2 solutions, 3 and 7. Let's do one more. Let's take a look at, let's see, this one. So remember that anything to the 1/4, this is the same thing as the 4th root. So this is no different. And to reverse this, we just have to raise both sides with an exponent of 4. So this will cancel the root and the exponent. And what we did to one side, we have to do to the other. Cancels root and exponent. What we're going to get, x minus 2 is 3x minus 8. And then solve for x. Divide by 2. So we get an x is equal to 3. So let's test this out. Does this work? So is 3 minus 2 to the 1/4 equal to 3 times 3 minus 8 to the 1/4. Or put another way, is the 4th root of 3 minus 2 equal to the 4th root of 3 times 3 minus 8? Or is the 4th root of 1 equal to the 4th root, where I put my question marks, 9 minus 8? Now again, it's an even root, so positive and negative matter, and so these are positive roots, so we're okay so far. Now, the 4th root of 1, one of these is a number, it's like 0. I mean, the 4th root of 1 will be 1, the 3rd root of 1 will be 1, the square root of 1 will be 1, because 1 times 1 times 1 times 1 is 1. Multiply 4 ones together, you're still going to get 1. So this is 1. And is this going to be equal to the 4th root of 1? Well, of course it is, because we just figured out what the 4th root of 1 was. So the answer checks out. So our answer of x equals 3, it's not much better. A set containing only 3, that's a solution. So that's it for 7.6. If you have any questions, let me know. Other than that, have a great day.